Saturn's moon Titan has been called the most Earth-like world found to date. It's the only other place in the solar system where stable liquid sits on the surface. Seas of liquid methane flow into channels that have created magnificent canyons, and scientists have suggested that the icy world might be able to support some kind of alien life. Now researchers think they can add yet another Earth-like quality to Titan's extensive list. According to a study in Geophysical Research Letters, a seemingly impossible cloud on Titan may be created by weather processes we've seen before at home. The unlikely cloud type was first spotted decades ago by NASA's Voyager 1 spacecraft. It was made of a carbon and nitrogen-based compound called dicyanocitylene, C4N2. C4N2 is part of the chemical cocktail that cloaks Titan in an orange-colored haze. But high up in the stratosphere where this particular cloud sat, the compound was scarce. Scientists could find just 1% of the amount of C4N2 that should have been needed to create the cloud. NASA's Cassini mission recently spotted a second example of this crazy kind of cloud. When they used Cassini's instruments to puzzle out the chemical composition of the ice cloud and its surroundings, scientists came up with the same impossible answer: the stratosphere-dwelling ice cloud is made of dicyanocitylene. But the stratosphere is sorely lacking in that particular compound. Clouds aren't unusual on Titan. They form when methane cools and condenses, just as clouds made of water form on Earth. Things are a little different when they form in the stratosphere. At the moon's poles, circulation patterns force warm gases down until they sink, cool and condense, but in both cases, the clouds form when ice and vapor reach a state of equilibrium. In the case of these strange ice clouds on Titan, the amount of dicyanocitylene vapor present in the area shouldn't be enough to keep the ice trapped in the cloud in equilibrium. The appearance of this ice cloud goes against everything we know about the way clouds form on Titan. Lead study author Carrie Anderson of NASA's Goddard Space Flight Center said in a statement. But Anderson and her colleagues think they've found an answer: in the clouds that damage Earth's ozone layer. Earth has certain clouds that forego condensation altogether, forming instead through a kind of solid-state chemistry based on the interactions of ice particles. On Earth, these guys are bad news. Chlorine-based chemicals enter the air by way of pollution on the ground, then meet up with icy water crystals in the dry stratosphere. The chemical reactions that occur in these wispy clouds release chlorine molecules, which eat away at the ozone layer. On Titan, a similar process could create the mysterious ice clouds. Anderson and her colleagues suggest that cyanocitylene, a more common compound containing hydrogen, carbon and nitrogen, could become coated with hydrogen cyanide as it moved down the stratosphere in the form of icy crystals. If ultraviolet rays from the sun struck one of these dual-layer ice crystals, the resulting chemical reaction would release dicyanocitylene and hydrogen. Voila! A cloud. The compositions of the polar stratospheres of Titan and Earth could not differ more, Goddard's Michael Flazer said in a statement. It is amazing to see how well the underlying physics of both atmospheres has led to analogous cloud chemistry. The Cassini orbiter has been studying Saturn and its wonderful moons for over a decade, but the mission is coming to a close. The mission will end in September 2017, but first NASA is undertaking a grand finale in April. Cassini will dive into the space between Saturn and its rings, an area never before visited, 22 times. On September 15, 2017, Cassini will dive for the last time.